We're given this rectangular prism, or cuboid as we used to call them in the UK, and we can see that the lengths going in this direction are 25 centimeters, the height is 10 centimeters, and the width is 15 centimeters. We want to start by finding the length of BF. Now BF is just in the bottom rectangle. So if we just draw that bottom rectangle like so, then we can see that this is 25 centimeters and this is 15 centimeters, and BF goes across here. So of course we can work in a right angled triangle just here. We know that rectangles have right angles, and so we can use Pythagoras' theorem. So this length is BF, and that clearly is the hypotenuse. So BF squared is going to be equal to 15 squared plus 25 squared. So let's just work that out. So 15 squared plus 25 squared is 850. And so BF would be the square root of that. So that's 29.1547 and so on. And if I give this to two decimal places, that's 29 point, this is a 4, so it doesn't round, 15 centimeters, correct to two decimal places. So now let's look at part B. We want the length of BE. So BE goes through the rectangular prism like this. We can form a right angled triangle here. So let's just draw that. So we're working now on part B, and we have this right angled triangle. Well, that's BF, that's FE, and then we have BE like this. So this is B, F and E, and we're trying to work out this length here, the length BE. We know this is right angled, we know this is 10, and we've just worked out the length of BF. So BE is the hypotenuse, so BE squared is equal to 10 squared plus BF squared. Now I don't need to re-square this, we know BF squared from just here. So that's going to be equal to 10 squared plus 850, and that way we get an exact answer. We don't work with decimals and things like that that might not square exactly to 850. So bring in the calculator, and 850 add 10 squared gives us 950. We want BE, so we need to square root the last answer. That's 30.8220 and so on, which is 30.82 centimeters, correct to two decimal places. Now the reason that I went back across here and used this value here rather than using this value is that what you can do by using rounded figures is build in inaccuracies. So we may not have got this correctly to two decimal places. We may have, but we may not have by using a rounded figure. So whenever you can, always use exact values, or make sure you use the whole value on the calculator and not a rounded figure.